Hello students, today we will see condition for zero resultant vector. If three vectors are acting on a point object at the same time are represented in magnitude and direction by three sides of a triangle taken in the same order, their resultant is 0. Now the object is said to be in equilibrium, or object is in equilibrium. So this is the condition where we will get the zero resultant vector. What is here? It is said that if in a point three vectors are working in this way, that these three vectors we can represent by a triangle. For example, you can see here, this is the vector, okay. So suppose we'll say this is vector A, this is vector B, and this is vector C, okay. So we can represent this in such manner that this vector is A. Here you will see this is A, the same length and the same direction, and this one is the, you can see here, this is a straight line, this is the vector C, and this one is the vector B, suppose, okay. So this is vector B and this is vector C. You can just look at here that if I am telling to you the length of this vector and the vector A, this is in this direction, the vector B, you are looking here, this is in this direction, and the vector C, it is here in this direction. So what we have done, these three vectors which are working at a point, so we are representing this three vector with the three sides of a triangle. So we will see here it is A, B, C in the same order. So what we can say now, suppose I am just writing here the side of the triangle in this way, A, B, C. So as we know from the triangular law of addition, AB, look at here, AB plus this is BC plus BC, and that must be equal to AC. That must be equal to AC here, okay. So this AB plus BC and AC, if we will transfer this side, right hand side, it will come AC minus AC, it will become, and equal to 0. Now you will see here, this is AB plus BC, and the vector which is represented by AC minus AC, we can write this as plus CA, just opposite of AC. So we will write this plus CA here. This will equal to 0. Now you will see this AB is representing B vector here, BC is representing C vector here, and CA is representing A vector here. What the resultant is now? The resultant of this three vector is 0. So this is called what? The condition for zero resultant vector. That means if three vectors can be represented, three vectors which is working in a point are represented with the three sides of the triangle in a same order, so the resultant would be 0. Lamis theorem. First of all, we'll see the statement. Lamis theorem statement is, it states that if three forces acting in a point are in equilibrium, then each force is proportional to the sine of angle between the other two forces. Here the three forces which we are taking are in equilibrium. The meaning of equilibrium is that that three forces can be represented by the three sides of the triangle in same order. So here I am just making a triangle and representing three forces. Look at here. This is a triangle. It is A, B, C, and three forces which are working here. Suppose here this is A, this one is B, and this one is C. So these are working in this direction. Look at here, I am just taking clockwise direction, so same direction it is working. We know that just now we have studied about the equilibrium forces or the vectors which are represented by the three sides of the triangle. Three sides of the triangle in the same order are giving zero resultant. That means here if we'll write this AB plus BC plus CA, so it is equal to 0, or A plus B plus C equal to 0. That means these three forces A, B, C, these are in equilibrium. Okay. Now what Lamis theorem is telling here? It is telling that the force and the sign of the angle, the force which is represented by the side of a triangle here, and the angle between the other two vectors, the ratio of these two are equal. So you will see here, suppose this is the force A, and now it is the angle here, angle between this we can extend. So the angle between these two vector here is alpha. Okay, if I will extend this line, so the angle between, this is the angle between B and C vector, the alpha is the angle between B and C vector, and this beta is the angle between the C and A vector, and you will find that this is the angle here, gamma I am taking, and it is between A and B vector here. Okay, so according to Lamis theorem, it is force A and sine of angle between other two vectors, that is alpha, is equal to force B, and sine of angle beta equal to C, and sine of angle gamma here. So according to Lamis theorem, this relation should be implemented for the vectors which are working at a point and giving the zero resultant, or you can say simply by in the force which are working in a three sides of a triangle, or the force which are giving the zero resultant. So we can apply the Lamis theorem in that type of forces or any vector. A single vector which balances two or more vectors acting on a body at a same time is called an equilibrium vector. So here we are talking about equilibrium vector. That means a single vector which balances other vectors, two or more vectors. Okay, it is equal and opposite to the resultant of various vectors acting on the body at same time. For example, you can see that suppose this is an object in which many forces are working. Vector, that means force is also a vector quantity. So I am taking here an example of force. Suppose at this point too many forces are working here, F1, F2, F3, this way. Okay, and the resultant of all these vector, suppose F1, F2, F3, and suppose n vectors are working, Fn, I am writing here Fn. N vectors are working. So the vector quantity which is balancing all these vectors or resultant of these vectors, so that vector quantity, that is, suppose I am taking here F. This F is balancing all these vector quantities, that means these forces. So this force or this vector quantity is called equilibrium vector of these vectors. Okay, and you can see easily here, this is equal to what? The resultant of this vector. This equilibrium vector is resultant of these vector, and obviously you will find the direction of this vector is opposite to this, because what you will find, the resultant of these vectors, the direction of this vector is opposite of the resultant of this vector. How it is? Just look here. This is F1 plus F2 plus F3 and so on plus Fn. Now if you will take this F this side, what you will find here? It is equal to minus F, and that is equal to 0. That is equal to 0 here. Okay, so this is the resultant of this minus F. So resultant of this quantity is whatever it is, that is balancing by F here. Okay, and it is giving 0 here. So obviously this vector is positive, the resultant of this vector is positive, and you can see this is the negative vector. So direction is opposite. This, the equilibrium vector's direction will be opposite of the resultant vector. Okay, so this is all about the equilibrium